Welcome to Ask and Learn.
Hi, let us look at another problem. So, imagine you have two rails and there is a rod on these rails which is attached by some sort of ball bearings or pins such that the ends of the rods are only constrained to move along the rails as shown by the arrows. So, this rail is not horizontal, it makes an angle 15 degrees with the horizontal, and let's say the velocity, so you are pushing, let's say you are pushing this end of the rod, let's call it B. So you are pushing rod B up on the rail with a velocity 6 inches per second. So if you are pushing this up, then this end of the rod will also go up. So if it goes up, then this angle theta will change. But let's say we are looking at an instant where theta is 40 degrees and the length of this rod is 20 inches. Okay, so let's call this end A. So somebody may ask, what is the velocity of A if we are pushing B with a velocity 6 inches per second? So let us try to find this out. So remember, as we discussed in the first problem and other problems, that any complicated motion can be broken down into translation plus rotation. This is the basic principle which we will use in all the problems. And for translation, remember that this is the velocity is same for all points. This is kind of definition of a rigid body, that if you translate a rigid body, all points will have the same velocity. Okay, so let us draw a diagram for this. So this is our rod and it's moving with a velocity 6 inches per second at an angle 15 degrees. So if this is horizontal, then we know that this is our velocity at 15 degrees. So this is V, and so all the points will have the same velocity. So point A will have this velocity, which is, let's call it V naught. So we'll have a velocity V naught. Okay, plus, so this is translational part. Rotational part. So let us take the axis of rotation to be point B fixed. And since the rod is moving up, and so the omega, the angular velocity is going to be in this direction. You can imagine by taking your right hand and doing the right hand rule by curling your fingers along the direction of motion, which is going to be up. So omega is going to point downwards. This is our sign convention, x and y, and z is coming out. So omega is going to be minus k if we write down omega in terms of vector notation. But here, omega is like this. So the velocity is always, radial velocity is omega cross r. So it's always perpendicular to both omega and r. And given the direction of motion, we know that the radial velocity is going to be in this direction. So let's just write this as vr. Okay, so now we have required quantities. So let us try to add them and get the final velocity. So at point A, what are the velocities? So we have V naught at an angle 15 degrees. And we know that VA is going to be in this direction because it's constrained to move along the rail. So it can only move in this direction. So VA is going to be up. And then we know that if this was our rod, then VR is going to be perpendicular to the rod. So most of these problems will actually be like problems of geometry where you are figuring out various angles and doing vector addition. So most of the problems in rotational kinematics are basically made complicated just by the geometry, not by the physics. Physics is simple. Translation plus rotation. Always remember that. Okay. So let's break all the velocities along the VA and perpendicular to VA so that we can add them. So right? So this angle is 40. If this is our horizontal line, then this angle will be 50 because this is 90 minus 40. And then since this is perpendicular, this angle is 90. So this angle will be 40. Okay, so now we have figured out most of our angles. So let's just write down the vector equation. We will need cosines and sines of 40 degrees and 15 degrees. So let us quickly try to look up a table and write down those values. So cosine 40 degrees is 0.76. So cosine 40 degree is 0.76. Sine 40 degrees is 0.64. Cosine 15 degrees, let's find that out. So let's write sine 15 first. Sine 15 degrees is 0.26. And finally, cosine 15 degrees is 0.96. Okay, so now we have all the required values. So when you break down all these vectors, let's write it down cleanly. So when you break down these vectors, VA stays here, VR will break down into a component here, which will be VR sine 40 degrees, and then a component here, which will be VR cosine 40 degrees, and then V naught will break down into. So VA is basically going to be coming from V naught plus VR. So we actually don't need to write this VA here. So this was just to indicate that VA is going to be along this direction. So we have broken down VR. This was our earlier VR. So let's break V naught. So V naught will be V naught cosine 15 degrees, and then this will be V naught sine 15 degrees. Right. So VA in vertical direction is going to come from V naught sine 15 degrees plus VR sine 40 degrees. This is equation 1. And then there is no motion in the perpendicular direction. So these components will have to cancel. So VR cosine 40 degrees is V naught cos 15 degrees. This is equation 2. So if we solve these two, then basically we can get our VA in terms of V naught, which is known. So let us do that. So we will look up values from here to help us. So this is 0.76. VR equals cosine 15 is 0.96. And then this is V naught. So VR is 96 over 76 V naught, and 96 over 76 can be simplified as 1.26. So this is 1.26 V naught. By the way, once you know VR, you should also remember that magnitude of VR is omega cross R, which is going to be omega L sine 90. So omega L. So you can also find out omega quickly from this. So So we get our omega from here. Omega is going to be 1.26 V naught over L. So we can put numbers for V naught and L. So 1.26 V naught was 6 inches per second, and then length was 20 inches. So inches cancel. So the units is 1 over second, and this is correct because radians are dimensionless. So this number, so let's remove 1 0 and push this decimal point one place behind, and then 2 3s are 6. So this number is going to be 3 6 are 18, 3 2s are 6, plus 1 7, and then 3 1s is 3. So 0.378 radian per second. This is going to be our omega. Okay, coming back to VR now. Sorry, VA now. So VA is V naught sine 15. So sorry, VR sine 15 plus VR sine 40. So VR is, so let me just write this down, sine 15 degrees plus sine 40 degrees. Now VR we have figured out here. So 1.26 V naught. And what is sine 15 plus sine 40? Let's look up our table. So it's 0.64 plus 0.26. Okay, 0.64 plus 0.26. So 4 plus 6 is 10, 6 plus 2 is 8, 9. So it's 1.26 to 0.9 V naught. And V naught is actually, let's just write the value. So V naught is 6 inches per second. So this is going to be, let's calculate this. So let's do it one by one so it's easier. I won't use calculator here. So 9 6 are 54, 9 2s are 18 plus 5 23, 9 1 is 9, 11. So and decimal after 3 digits times 6 inches per second, and when you multiply it by 6, 6 4s are 24, 6 3s are 18 plus 2 20, 6 1 is 6 plus 2 8, and then 6 1 is 6. So 6.804 inches per second. That's going to be our VA. So what are the basic points here? So I'll just write them down so that you remember. So remember, to solve any of these kind of problems, all you need is to break it down into translation plus rotation. And translation is same velocity for each point. So this is your first step, and then second step, you do this, and then the second step is break velocity components, which are translational and rotational. So break velocity, which is translational plus rotational, into components perpendicular to and parallel to the motion you want to study, and add the, so you break this. Third is add vectors and solve. So you do these three things and any of these kind of problems can be solved easily. See you in next problem. Bye.